Hi, this is Nancy Priya from CSE Department, Perry Institute of Technology. This video is for BE CSE students, 3rd year, 6th semester 2017 regulation. And the topic is from the subject compiler design from the unit 2, which is syntax analysis. So this video is the continuation of introduction to LR Parser, part 2 video. And in this video, I am going to explain you about LR0 parser and SLR parser. So as I told you earlier, LR0 parser and SLR parser make use of LR0 items. So LR0 items means you have a grammar, right? So when I add a dot to the right hand side production, it becomes closure, as I told you earlier in the previous video. So this altogether is called as LR0 items. Production with dot symbol at the beginning is called as LR0 items. So this LR0 parser will make use of these kind of productions. Okay, let's move to the problem now. LR0 parser. So I have given you an example grammar here. S tends to capital A, capital A tends to small a, capital A or small b. So this is my grammar that I am going to take, and I am going to parse and find the parsing table now. So the step 1 to proceed with the problem is we have to find the augmented grammar. So as I told you earlier, augmented grammar is nothing but we have to add a dash to the starting symbol. It becomes an augmented production, and the whole grammar will become the augmented grammar now. So which means that S tends to S dash tends to S. Now this becomes the augmented production. Why? Because S is my starting symbol. I have just added dash to the S, and this becomes my augmented production now. So what happens to my augmented grammar? So S dash tends to S tends to capital A, capital A tends to small a, capital A or B. So these two are the productions right from the question as such, but I have just added an augmented production in first. So adding dash to the starting symbol will become the augmented production, and as a whole now this is called as augmented grammar. This is my step 1 procedure. Coming to step 2, we have to find the closure for the given grammar. Okay, as I told you in the previous video, closure is nothing but adding a dot symbol in front of the production. So now we have a production as now we have the grammar as augmented grammar. So we have to find the closure for the augmented grammar now. That is step 2. So S dash tends to dot S tends to dot A tends to dot AA or dot B. So this is my closure now. I have just added a dot symbol in front of every production on the right hand side. So as a whole this becomes a closure. So step 1 is we are going to find the augmented grammar. Step 2 we are going to find the closure. And coming to step 3. In step 3 we are going to find the go to operation. Step 3 as a whole, it is going to be called as canonical collection of LR0 items. So what I am going to do here is we have found the closure, right? S dash tends to dot S. That means applying dot on the right hand side. So by taking that closure part, I have taken it as a whole, as a state called I0. I have just named it as I0. I0 is nothing but state 0. So as a whole, this grammar has been taken as state 0. So what you are going to do is on this state, we are going to move the dots to the next position one by one. Let's take the first production. So how does the dot move to the next position? Only by crossing, parsing through yes. So as I told you in the first video, by traversing through yes, I0, on traversing through this yes, I am going to the next state with the production S dash tends to S dot. S dash tends to dot S. So dot has to move to the next position. So if that is the case, I have to parse yes. So on parsing yes, I am moving to the next state called as S dash tends to S dot. So I am going to name it as state I1. Coming to the next production. So you have to solve it one by one. Coming to the next production, dot has to move to the next position. So what I have to do, I have to parse A. So on applying A, I'll be moving to the next position. So the dot has been moved from the beginning to the next position by passing through A. So here an important point to be noted, that is, since you have a non-terminal next to dot symbol, you have to add this non-terminals production in the same state. So the non-terminals productions are A tends to dot AA, A tends to dot B. So these two are the productions given in the question. We have just added a closure here. So since dot is preceded by a capital A, which is a non-terminal, I am adding the productions of capital A. So now this become the next state. Okay, next coming to the third production. So dot has to move to the next position. If that is the case, I need to traverse through small a. If I pass through a small a, the dot will be moved to the next position. So if dot is moved to the next position, what will be my production? A tends to A dot A. And here also the same case. So dot is preceded by the non-terminal. Therefore, I am going to add the productions of non-terminal again. So A tends to dot AA, A tends to dot B. So this becomes my next production, next state. So my last production is A tends to dot B. So dot has to move to the next position. If that is the case, I have to traverse through B. So now A tends to B dot. And this becomes my state. So I am going to name it as I2, I3 and I4. So looking at the states, so this is my first level state, which is I0. My second level state is I1, I2, I3 and I4. So now I have to see I1. So in I1 state, the production reached to the end of the string. Dot has been reached to the end of the string. No more symbols next to dot. So this state has reached its final state. So we are not going to do further work on this state. Coming to I2, here I have a non-terminal, which means an element next to A. So what does it mean actually? We have to traverse one more step to move the dot to the next position. So I am going to traverse it here. Dot has to be moved to the next position. So the actual goal of the problem is you have to bring the dot sign to the end of the string, the end of the production, to the final state. So till that we have to do the process. So I am moving the dot to the end, which means I have to traverse through A. If I have to traverse through A, what will be my production? S tends to A dot. S tends to A dot. A is moved, dot is moved one step with traversing A. So this is my state here. So my next production is A tends to dot A capital A. So the dot has to move to the next position by traversing small a. Here on small a, I'll be moving to a position capital A tends to A dot A. And since dot is proceeded with capital A, which means a non-terminal, I will be adding its production again. So A tends to dot A tends to dot B. Why am I adding it here? These are the original grammar given in the question. So since the dot is preceded with a non-terminal, I am adding it here. So look at this state. Now this becomes a state, right? So look at this state and this state. They have the same elements here. So instead of creating a new state, what we can do is we can just link it with this state upon A. So we no need to create a new state and create a delay in the process. We can just connect it with the state I3 so that you can reduce the state also. So coming to this production, A tends to dot B, we have to move dot one step to reach the end of the production. If that is the case, I will be getting A tends to B dot, right? So I have it already. So what I am going to do is I am just going to link it with this process by specifying it as B. Hope that is clear. Instead of creating a new state, if the state already exists, we are going to just connect it with the state. Okay. Now coming to I3. So in I3, we have production A tends to A dot A. So this dot has to move to the end of the string, which if that is the case, I have to traverse through capital A. So if I traverse through capital A, I'll get a production A tends to A dot. Since dot has reached the end, nothing has to be done here. So this becomes a state now. Next, A tends to dot A. So if I have to traverse, what I have to do? On applying small A tends to A dot A. I'll be getting A tends to A dot A, which is nothing. I'll show you separately. The similar way. So if I have to traverse through this, I will be moving with this A again. I'll getting the same production. A tends to A dot A. I'm telling you for this one. If I do for this, I'll get the same thing. Since I have a non-terminal, I'll be doing the same thing. So if I have the same value, instead of using one more state and wasting time, so we can directly link it with this production as a loop. Since this has the same value, we can just have a loop here and link it with the same state. Similarly, A tends to dot B, right? So if I traverse through B, I'll bring the dot to the end of the position. Then my production will be A tends to B dot. I already have the production here. Therefore, I am linking it with this production by specifying it as B. Okay, now we have to number the states. I have already numbered with I4 here. So I am going to number it as I5 and I am going to number it as I6. So initially we started with the I0 with all the dot symbol at the beginning. So by traversing each and every element, we will be moving to the next position. So if we have the same elements, which mean the same production or the same state, instead of creating a new state, we can just link it to the state, or we can either form a loop. So this is my third step. So with this, I conclude the session. I'll solve the LR0 parsing table and the SLR in the next video. Thank you.